So Tarun, hello Tarun.
Yes, go ahead.
Good evening.
Yeah, good evening.
So can we say indexing is like sorting of data in order?
Sorting, it's not sorting the data, it's creating a list of pointers, as I explained, that you have a table, right? So let me share you here the picture. I'm sharing my screen also, and then in that you learn. So in the table, assume you have columns, right? So you get, say, for example, multiple columns in a table. So, and then you will have rows. Actually, the way the data is stored is these rows in the table will be in the order of insertion. Yes. So assume there is a salary here. I can insert someone with, say, 1,000 as a salary. Later, I can insert someone with, say, some other salary, 2,000. Right? So first record 1,000, second record 2,000. I may again insert another item, say 1,500. Right? So here the data is in the order of insertion. It is not sorted. But when you create an index, is what you are creating is you creating a B tree. And as we saw, there are different kinds of indexes, but I'm considering we will be having a B tree. Right? So assume we have this B tree. So internally, when these tables are stored, you will also have the address. Yes. For these records, right? Internally, this will be handled by the database. Or you can think of that these are kind of some kind of pointers. Yes. So what these records will be pointing is this is pointing to this. Right, because the lowest value. This will be pointing to the middle value. This will be pointing to the largest value, right? So you are getting some pointers which get created. You may be updating the record also, right? So maybe the guy who was having 1,000, this got promoted and now his salary is now this. So you have to readjust the indexes, right? Because it's a very dynamic thing. And then now something will, maybe everything will change here.
This right. So reindexing will be done manually.
Yes, this is reindexing. This is what.
So it will be done manually, or we'll be having some reindexing related index to basically do it automatically.
Yes. Right. We should understand that reindexing will happen only when there is no load on the data. Database may not do it because this is a heavy operation.
Yes.
So it may be done in some background process after some time, right?
Okay. So
So
you are
it
saying
may
that.
not happen if suppose in a heavy loaded system, it may not happen at all. You
Okay.
have to use the reindex command to do the indexing again.
So
And
is it some manual process?
yeah, there is a command, reindex.
Uh-huh.
I covered last time also that command,
Yes, yes, yes.
right?
Correct.
So there is
So
a reindex command which you have to run. So basically, while monitoring your queries, if you notice that some of the queries are taking longer now, earlier they were running faster, now my database has become slow, then one of the reason could be your index has become outdated. So you please run reindex. Yes.
okay. So but
That
it can
will,
also be done automatically as well, right? Just by
yes,
writing
it
some
can be
script and
done.
all.
It is most of the time done automatically because yes, it's like garbage collector, right? You believe that your memory optimization will happen, but sometimes you will get out of memory. So it's better to deal with it separately also, like by running reindexing.
And one more thing, just want to
And
understand.
another situation is, yeah. Okay, tell me.
Yeah, please, you can go ahead, then I'll ask.
See, index you may create at later time also. So you will keep creating and deleting the index also. Yes. So sometimes I may feel, yeah, this is not required. I may delete it. Yes.
Right. Yeah.
So yes, indexing is something which can be done at later stage, or if it is done at the beginning stage, then you have always opportunity that index will be re-indexed. But what if there are already millions of record? Now you have created and then you inserted again in one go, again another million record after creating the index. So you may have a situation where your index is not performing well. So you have to do re-indexing.
Okay. So
Yes.
my question was, I think, yeah, re-indexing, you can do it later. Yeah. So let's suppose there are 10,000 record in DB, right? And if you're doing indexing first time, then definitely it is going to take some time, right? But let's suppose few of the record, let's suppose 50 record has been here and there because of some update. Let's suppose on salary column. So
Yes.
if you'll do re-indexing again, and so will it actually take more time? I mean, same time as previous, or it is going to kind of, only adjust those 50 records which actually got updated, and that.
Indexing slows down the insert, delete, update operations.
Yeah, that's correct. So my question was that, let's suppose you have done indexing first time for 10,000 record, it has taken, let's suppose, 5 minutes of time, for example. And if 50 record got updated, let's suppose salary, which got updated, and if you're doing re-indexing again on the same 10,000 record, but 50 record only got updated, in that case, if you do indexing, will it take 5 minutes again, or it is going to take just 1 or 2 minutes, something like that?
Yes. See, again, it is up to the database and settings, how different databases may deal with it differently. But yes, here, what I'm saying is if you are doing bulk updates or many modifications, there could be a situation where your index has become outdated, but database will always do its best to ensure always the indexes are up to date. So you can assume that most of the time your indexes will be always up to date. But as we saw also, there are some bugs. Sometimes some tricky situation happens because of which something may not be expected. In this case, you have to do the re-indexing. So 80% of the time, you don't need to worry about re-indexing, but in some specific situations, maybe 20% of time, you have to worry about re-indexing and you have to run re-index commands manually. Yes, nothing is perfect in this world. So that's why there is reindex. But yes, it is not that bad also that you have to take care of reindexing. No, that option is not there because in SQL, right? So I see one question, which is an interesting question. Can we switch off the indexing or disable indexing and then insert and delete and do whatever we want? And then after inserting later, enable it. Yes. So in databases, in SQL, you do not tell how part. You only tell what part. So in SQL, you never control about how to do things. You just say select these records. Maybe they are running for loop first, or they are doing some joins or whatever they are doing. Databases will decide by themselves how to get that data. Right? Because if you write it in Java, C, C++, you'll have to code for I equal to 1 to Z n, right? If this is greater than 100, then insert it into an array, whatever. You have to tell the how part. But here you don't have to tell the how part. You just say what and they will do they decide, database decide by themselves what is the best thing to do. You don't worry about, you don't instruct, it does not takes your instruction. It takes, it do the way it likes. Right? So that's there. Anything about transactions? Okay, let's also do some more. Now you guys have questions about indexing, and you would be wondering about how to see the performance of various queries. Yes. Right. Okay, now a few things again I will tell you that you will say, okay, when you have to reindex, why not delete the index and recreate it? Yeah, that's also possible. Yes. But yes, you should not do it frequently. Yes. Reindexing is like you are running the disk fragmentation, right? There is a tool, in Windows you need sometimes. But yes, most of the time operating system has to be optimizing the hard disk such that you always never have any performance issues. But as you use the operating system, you install, uninstall various applications, your operating system becomes slow. Then the recipe is you do some system maintenance, run disk defragmenter. But yes, you don't do it every day. Same way, you don't do reindexing, because reindexing when you run, it may lock the table and it may slow down the performance of the queries while the reindexing is running. Yes. Also, there is another way is drop the index and create it again. So that is also another way of doing reindexing. But yes, you do it in non-peak hours. If you know that, yes, this time very less users are there, you do the reindexing during that time. So yes, we were talking about some code examples. Yes. So yes, let's say if our employee table is still there. Let's see. It's not there. Okay, so let's create the employee table.
Database is actually same. I mean, it's a default one you created. Or
The database.
yes, yes.
Yeah, I'm using this online tool, so it is having the database on the cloud. So
Okay.
it do take away the database after some inactivity, right? So
Okay.
yes, it has taken away, but never mind. We will try to get it back quickly. Right. So I'll create the employee table. I have these commands noted out with me, so it's not a problem for me. Let's create even bigger employee table because yes, we have this employee table. Not worrying about primary key, foreign key, etc., for the time being, because we are focusing on indexing, reindexing, right? Now let's insert some data. Right, so let me insert some data into employee table. Let's insert, so yeah, we have employee ID, first name, last name, email, phone number, hire date, job title, department, managers, manager ID, basically manager ID. Manager ID could be the employee ID. So it is a self-referencing, right? So let's insert, I'll run the, is this clear? I'll replace this with the insert command. Yes, so I got some 10 employees, all these employees. I run it, they got inserted. Clear? Okay. So this is how I insert into employee ID. I list down the columns, and in the same sequence, I list down the values. I had some null fields also. Many employees don't have the manager. They are the happy employees. Some employees have managers. So they are the one which is not that happy. But yes, now we have run this. We have the table. So let's run the query. We just list down all the employees. Right. So I use some naming convention I follow is I use the capital letter, first letter capital, sentence casing for table names. Keywords are all caps. It's case insensitive. I can use anyway. But yeah, this is the convention I'm following. Formatting also you can use here. There is a code formatter When you run, you see the results. Immediately it's showing the result. Yes. Now, yeah, you can index on hire date, you can index on salary and all. There is a command called explain, right? If I run this, let's see what happens. Yes, see. What it has done is it has explained how it is doing. It's saying Sequency is spanning on employee table and saying the cost is 0 to 11. And there are, yes, it gives 100, rows are 100 and width is 776. It's giving some background details. Right. See, this is important command for optimization. So you explain followed by whatever query you want to give. Yes. In this case, I have the query. You can run this with any query. It will give you the explanation.
But we do not have any output as of now.
It does not give the output. Right? It just explains the
how many rows is there.
Yes, right.
But,
so let's
but
say,
do we have 100 rows?
Yes, it may be by default it has created size 100, right? It may mean that the size of the table is 100, but yes, we have only 10 rows.
Correct. And what does the cost mean here? I mean, how do we understand?
Time. Cost is how much time? Now, see, now it's saying rows 33. Okay, changed. The cost has slightly increased 11.25. And it says, okay, I'm doing sequential scan on employee, and then I'm doing filtering on this, right? Basically, what actually happens when the query is run, there is an optimizer also. Database optimizer plans how to execute the query. And this is the query plan. Yes, you see here the title query plan. Query plan is there is a database optimizer. It will first create a query plan and then the query will be executed. Now, in the query, in the explain command, you have various options also. Okay, let's play around with some more thing. Let us say the first name. How did I write it? F-name. Yeah, like this. Let's retrieve first name, last name, salary, right? And let's say ID also. Let's say, now what happens if I say explain? This I called employee ID. So now if I run explain, okay, what is column does not exist. It do exist, right? So let's see. First name and last name. Yeah. Now I run. Yes. So it does not matter much here because columns does not contribute to additional cost. Yes. But let's see what all options we can say. We say analyze. Actually, we have another command also, like this also we can run. Explain, analyze. See here, it's giving cost, it's giving execution time, it is giving planning time. Cost is basically, see here, there is a difference between these two commands. And now you will ask, what is difference between the cost and execution time? Anyone? No one knows about this explain, analyze, and explain commands. When you are seeing the execution time, what does it mean? Does it execute it? Or just giving you some number by guessing?
Is cost mean some kind of space related to space?
No. Now let me explain you. Cost is the estimated time, right? And they use their own convention. See, the cost will vary. It becomes sequential scan has some cost. So they have some number, which is a relative number for giving the estimate about the time. When I run explain, analyze, what it does is it is executing the query also, and it is giving me the time to execute. It took this much time for database to execute this query. So this is the real execution time. Explain, analyze has executed it and have given full analysis, which is not only just the cost, rows and width. It has given more details like actual time is at between 0.12 to 0.15. Because see, this is giving the ranges because this is all analysis. It's estimates. Yeah. So it says 5 rows it's giving now here. Loops 1. Correct? This is the cost. This is some cost. This is actual time. And this is execution time. Now let me explain you what does it mean. Query plan I shared. Query plan basically is a tree structure which shows the steps to execute the query, and there will be multiple steps to execute the queries. And each of these rows represent different steps. Right? So it says sequential scan on employee. Then it does filtering on employee ID greater than 5. Then it removed row by filtering 5. Right? So it got 5 rows filtered. Then it shows planning time and then execution finally. Scanning, this sequential scanning means scanning the entire table row by row. Now, let's create an index and see what actually happens. So let's create an index on which row? Yeah, I'm coming to other parts also, like what is difference between execution time and actual time. But yes, let's see what happens when we create an index. So let's say we create an index employee on salary. And this is how we create an index. On salary, right? So something like this. I run. It will create the index, right? Let's say I'll explain. Can I use explain on this? Let's see. Yeah, you can't use explain here. Here is saying syntax error. The error is not that intuitive, but let's forget about it because it's not a query. They understand it is some command, and command will not have an execution plan because it's not retrieving any data. Yeah, let's say now let's use select from employee. Yeah, where salary greater than, let's see what are the salary values. Yeah, so some people have 5,000, 4,000, 3,000, etc. So let's say 3,000. I run this. Sequential scan on employee. And then using a filter numeric value. 3,000 is a numeric value. It gets converted to numeric value because I have used like this. Actually, it's a money data type. Yeah, but it for running this query, typecasted it to numeric value. Yes. Okay. So let's say now I call this. I give this command. Right? Let's follow the convention. All are small, so it should be like this. So, but yeah, where condition I'll not give. And I will run this and see what is the explanation here. Right, this is aggregate, and the aggregate max is looking into all the salaries, and then it's giving the salary.
Taran, but earlier also the cost was same, right? I mean, what exactly did the adding of index made here?
Yes, yes. Right now, see, we are not using any query, which is, yes. So let's try something which will utilize, because here no index is never used in all these queries. Yeah, it's not getting used. But let's try something where index will get used. See this query where salary is equal to 3,000. Here probably index should get used. Okay. Still they have not used.
So how will come to know whether it's being used or not?
Yes, it will tell in the execution plan that index is getting used.
Okay.
Whether is the index applied on salary?
Yeah, we created index on the salary. Yes. Okay, let me try something more.
But you can see that there's a syntax error at the near index. Can you see that? Whatever you have actually.
Is it okay? Okay. Is no, but
Syntax.
then, that was for explain. But this got executed successfully.
Okay.
Let me try this, otherwise we'll create it again. Let me run this.
Once check all the available indexes on this table.
Yes. How to check?
Uh,
Yeah, that command I can't run here. There is a command to do that, but in Postgres database, not in this cloud environment. But yes, let me do this way. Let's say I do reindex. Let's see, does it changes? Reindex, I need to give what is the index, right? So my index is called IDX employee salary.
Index.
Yeah, reindex index
Index you have not
Use-
written.
like this.
Yeah.
And then, yes, semicolon doesn't matter. So it's done now. Now let's try explaining this.
I think you can click on that run button, right? Directly. Right side.
Yes, I clicked on that button, right? So that's why to execute explain command on this to see whether the index are used or not.
But it's still not, right?
Yes, it's still not. Okay, let's try something else. Yes. Create index customer and sorry. So let's say this employee. Yeah. Index, and then we have say salary and
On employee.
hire date, right? Hiring date is
Okay. Yes. No, the customer should be to employee.
yeah, I'll change to employee, right? So I'm
Actually-
using now an index which is on multiple columns.
What is the state there? State.
So it's salary. Yeah, it should be salary.
Yeah.
Hire date, right? So something like this I named. I say create index. Yes. Create successful. Index is successfully created. Yes. Now let me do so now we have two indexes. Okay, but let me try one. Okay, let me write the query first. Select says from employee, I would say where salary is 3,000 and hire date. Okay, something hire date.
We can ignore, I think. Higher date. At least only one filter. For now.
Can be greater than. Okay, yeah, something I give. Say let's see. Right. These are query and I execute. So you
Okay,
get
yeah.
some rows, right?
Yes.
Okay, let me see this. I'll put 2022, 4 and 0. One. Yes,
Okay,
sir.
you are trying to fetch a single record.
Yes, I want to get one item. Okay, all of them are greater than this. So let's say here I put 3. Okay, so I should get less record. Yeah, like this. Right. Now let's say here explain. Yes. I'll format it also for your readability. Yes. And when I run it, let's see. It does it. Okay. Let me call explain analyze. Yes, and I run it. Okay, somehow, yeah, this database is configured in a way, it is not showing that it is using the index. So, but yes, how you will get is, I have another environment also, don't worry, where I can demonstrate this concept. Here somehow this is not working, but the customer table I have created in another environment. So just give me a minute. So I will remove this part and I'll say format. Oh, it's already formatted, saying, okay, this index is fine. And this format, yeah, there is another query which I'm using, and we have an index already here. Right, like this. So this is your index, which is on state and date of birth, right? But this is, I have the table already created for me. And, but yes, I'm using another environment here. So let me just show you. Let me just take this formatted code here. And yes, I'm coming. Okay, so I have another environment, another database. Here I have this query. Yeah, explain, analyze, select asterisk from customer where the state is Texas and date of birth between these two values, between 1880 to 1990. Yes. My table, create table customer is something like this. Yes. And create index. I have created index on state and date of birth, which I demonstrated. I have many. See, I have here many rows. Correct. Now, when I run it, let's see, this is explain, analyze. So we should get the output. So here is the output. So index scan, it is saying here, see, index scan. It's not sequential scan. So this shows that index is being used. For you making it bigger, see here. This is how it shows that index is being used. Maybe we need more number of columns. That could be one reason. Yeah. Or maybe, yeah. What if we try this in this environment? But yes, we want to understand the concept of index. We don't want to play around and, but yes, see, this is how you will know that whether index is being used or not. Clear? Because we have to cover more topics, so I'm just skipping. But yes, maybe you can try is that exercise. Insert, say, 25 employees and see using explain, analyze whether it's using index. Maybe there is an optimization that if you have many rows, then only they do index scan. Yeah, you never know. Again, this is all specific to the database, is specific to the database version. From version to version, the way the database is optimized may change. But let's talk about what all these are. Sequential scan is scanning the entire table. Index scan is query uses the index to quickly find the data without scanning the entire table, right? So if there is an index scan, that means you're not scanning the entire table, you are scanning index by index. Then there could be heap scan also. Again, depending on different kinds of index, there will be. If you have some queries with join, you will also see about joins. And there could be sometimes nested loops also if you have joins and subqueries. And filter is, filter is removing filters. And rows means the number of rows which needs to be processed. Yes. Planning time is the time which is spent by the database engine to prepare this plan. And execution time is the time which is taken to execute this particular steps. Yes. The actual time is cost. It is an estimate. It is not the actual execution time. Actual time is the estimate. Basically, this is an indication of complexity. So this is always a range, minimum and maximum. Now, your question is why this cost is being shown. This is very interesting thing you should understand. When database is trying to execute any query, is it trying only one plan, or it would have tried multiple plans, multiple approaches? So what it would have done is it would have tried multiple approaches to execute this query. Maybe it has tried index scan also. But based on the cost estimation and actual time estimation, it is finding that this sequential scan is faster in this case, maybe because there are less number of rows, or the data is somehow there in such a way that this is coming lesser. So it's picking up one plan, and this first line, cost and actual time, etc., is required to compare two plans and pick the best one. So it picks the best one and executes it using that particular plan. So this is all about query optimization and how you can see that queries can be efficiently executed by the databases. Right? So yeah, play around. I'm not going too much in depth into this because yeah, we can go on and we can have a complete session on this and multiple sessions on this. But for we are doing this to understand the system design. And if you understand this at the basic level, you will be able to very confidently answer system design interviews. So that's why I'm giving you exposure to all these, because when you will be talking about index, the confidence level will be very different than the rest of the crowd who have not tried this. And then definitely, interviewer will be able to recognize it, and you will get better credits for this. Okay. Now, last time we saw transactions. Hope everyone remembers. So last time we covered index, we also covered transactions. So people remember what were transactions, what were save points, what were commits?
Acid properties. We
Yes.
have, yeah. Save
So
point.
correct, correct, absolutely right. So in transaction, you get atomicity, right?
Yes.
So let's go more in depth about transactions. So we saw a few queries. We have something called begin. Yes. We created the account table, right? So let's see if our account table is there or not. It should be there, I believe. No, account table is also not there. No problem. Account table was very simple. We had, I have the code also preserved with me. So you have account number, customer name, and balance, right? This was the account table. We got it created. We will be opening an account, right? So we'll create an account. We'll do it within the transaction. Yes. Always good to do it within transaction. So it got inserted. Twice I cannot insert the same record because the account key already existed, right?
Yes.
So we have the concept of save point. We can create a save point. Yes, like this. We can name a save point. We can perform some
I think
operations like
I'm not
update.
sure.
Yeah,
I'm
go
not
ahead.
sure whether save point was covered. I'm not sure about save point.
What is the purpose of save point? Is this what you are asking?
No, I'm saying that I'm not sure whether save point was covered before.
Yeah, I shared briefly that while you are rolling back, you can roll back to a save point.
Okay. Okay.
Yeah, yes, but yes, you are right. I did not cover it in depth because there is another command which you have to do, roll back to save point. Yes, you have to mention the save point name. So see, SQL is also very powerful and feature rich. So if I have to cover all the features, again, it will take a lot of time. But yes, this is what you remember. Maybe you have some other updates. So yes, like this, and you can always do like this and then commit. Yeah. So if you run it, and basically we have to verify this result by running the select query. Yes. I had CCC here. Yeah, it's a type of. I'll always follow the best practices. Always another good best practice is putting a semicolon. And you see here, 100 rupees is inserted. Yes. The other second transaction was rollbacked. Right. So this is the use of rollback. Yeah. See, what I did was I created update first. Then I update again 100. So it should have been 1200. But I did roll back to save point 1. So it rolled back. Yes. whatever was the state. But yes, once you encounter a rollback, it's like exception. This commit did not execute it and transaction was closed. So either commit will happen or rollback will happen. The transaction will get closed. Basically, I
Okay,
should
so
use the condition. Yeah.
in this scenario, if you're not using the save point, still that it will work in the same way, right?
No, then it will roll back to the beginning of the transaction.
Okay, you are saying that you have done 2 times.
Yes, I have done 2 times.
Okay, so current balance is 1100, and now it will be updated to something like 1300.
Correct, absolutely. But I am rolling back, so it will actually, this is of no use because rollback anyway will happen and commit will not happen. So if I run it, it'll still be the same 1100. Let's see. I did this. $1,100. Yes. This is what I did, but I did roll back. That's why. But if instead of this, I do commit and run.
1300.
Yes. So now yeah, 1300. Absolutely right. Yes. But yes, there is something more in begin also, which I did not cover, but this is very important from system design perspective. And locks also have to cover. So let me come back to my whiteboard because this is what I need to cover first, the concept, then we will do the command. So here we will be talking about transaction isolation level. Until now, we covered about atomicity. Now we will be covering, as I said, isolation, right? Concurrency. No, sorry, consistency and durability. So with this, we will cover all the ACID concepts practically also. But yes, here you remember this. This is ACID property. Atomicity, consistency, isolation, durability. And now we are covering this isolation level. Basically, transaction isolation level. They should have called, yeah, transaction isolation level, or I don't know, but yes, maybe they wanted to simplify it or form this good ACID abbreviation acronym, right? So that's why they called it just isolation, not the transaction isolation. So that's a cheating. Yes. But yes, what does it mean? See, in transaction isolation levels, you have various isolation levels. I'll list them out. There is something called read uncommitted. Yes. There is something called read committed. There is something called repeatable read. And then finally, there is something called serializable. Right? These are the 4 transaction isolation level. I'll put it here. I will define each of them. Yes. Okay, there is two more concepts you should understand. Dirty read and phantom read. Yes, all these terms are very important. If you know, you will be able to use them in system design interviews, and these concepts are very important. No one talks about it. But yes, if you know, then only you will be able to perform well in interviews requiring database designs. Yes, you would have seen many YouTube videos and all, very less people talks about it, but there's a very fundamental concept. You should understand it, then only you will be able to design good applications. Like if you are asked to design IRCTC, or if you are asked to design Book My Show, these concepts are very important. Now let me talk about what is dirty read. Anyone has the idea what is dirty read?
Yeah, I do understand. Let's suppose there's a lots of transaction which is happening, right? At the same time, someone is reading, but the transaction is not been, let's suppose, it's not able to read the updated one actually, due to some reason.
No, if the data is modified, but not committed.
Yes, not
called,
committed.
Right? So
Yes,
dirty read is reading uncommitted data.
Data, right.
Yes, but we see that this was not allowed in this case. In our case, we were only reading data which is committed. But yes, you may want some time to allow reading the uncommitted data also. But this will have the problem that it will lead to data inconsistencies. Because later you will either commit it or roll it back. If you are committing it, then it's fine. Yeah, you read uncommitted. But if you are rolling back, then inconsistency will happen. This is called dirty read. Dirty read is allowed in read uncommitted isolation level.
But how it can be read that if it is not been committed already, right? If it is committed, then value will be there in the DB, and then only it will read that value, right?
No, databases can allow you to read uncommitted data as well. Yes.
Yeah.
So, okay. I am not 100% sure, but let's try this exercise. Yeah, I will show you, because anyway, I want to show you the syntax of this thing. So this, how to get these isolation level. So let me try showing you that. Okay, let me try getting my PostgreSQL again. So we discussed that we had something called begin, right? Then we have something called, so begin, and then we have some update. So let's put an update query.
But I don't think so it can be replicated here, because there can be multiple transactions which will be happening, right? At the same time, you also have to read.
Yes. So with begin, and then let's try, because I think, yes, you are right. So with begin, we can say isolation level, right? Read uncommitted. Like this, I have given the begin. Then I'm doing this, right? And I'm not doing anything. So I'm now subtracting this, because 1300 is the current value. Yes. So when I run this, let's see what happens.
$1,300 is still. So I think that's fine. It's not reading, but uncommitted.
Yes, correct. So
Now if you commit and read,
I commit, then I would say again the same command. Yes.
still not.
Yeah, so right, so here we have this command. Let's say roll back here or commit. So yeah, because I think this isolation level can only be demonstrated if we have multiple transactions running at the same time. Yes. So
Yes, if you'll commit it here, then
yes, yes. But what you should understand is you may want the database to show the uncommitted value also. Yeah. Yeah, 1200 in this case because I committed. Yes. But yes, what I wanted to demonstrate is you can set the isolation level to any of these three by giving you this option. Yeah, I'll tell you why it does not happen. Yes.
so
And why then? Now your question will be, why the
Mhm.
hell is this command available when it is not performing that? But yes, this will be very interesting point for you. Yeah. So you can use read uncommitted, right? Or you can use here read committed, or you can use repeatable read. Yes. Or you can use serializable. So these are the four options available. Yes. I explained you what is read uncommitted. Now you also understand what is read committed. This is what is happening. Postgres do not support this. This is no, it does not support. Because if it supports, then the consistency will not be there and relational database have to be consistent. Now, but you will be asking why the hell is this command then allowed? This is allowed because this is as per SQL standard. SQL is a NC standard. So just to implement the standard, they are allowing it, but they are not doing it. Command is syntactically valid, but semantically not followed. And this is there because of SQL standard, because in some other database, if it is supported, you are porting the code will not crash. It will still be a valid code, but database will behave properly as it is supposed to as per asset property. So this is the least level of consistency or isolation, and it is not allowed in Postgres. Coming back, what is repeatable read? Right? So repeatable read is a read which is if you read multiple times, it gives you the same data. That is a repeatable read. You don't have configuration for dirty read. This is what Ramesh I'm talking about. Because if you allow a dirty read in Postgres, at least it's not there. Maybe in some databases, for example, Oracle may offer maximum flexibility. So you need to refer to the manual of the databases, which allows dirty read or not. But yes, Postgres do not allow dirty read. They do allow the command as syntax for compatibility due to following of SQL standards. But yes, repeatable read is the read. If you read multiple times, then you will get the same data. That is repeatable read, right? But yes, if you are reading the same data again and again and getting different values, this is called non-repeatable reads, because these are the problem. And then there is something called phantom read. Phantom read is basically is also kind of a non-repeatable read. But here you are reading the data multiple times, but you are getting different rows. This is what is phantom read.
So phantom read is also kind of dirty read, can we say?
Is a problem, the inconsistency. Yeah. So
Okay, so data is read twice, and different rows have been read in between. I didn't get that much.
yes, see here, this is statement I have just, I'll put this to the reply to the query which Ramesh has posted. PostgreSQL ensures there are no dirty reads in transaction, even in this mode, right? In the, yes.
Tarun, hello.
Yes, go ahead.
So if we include this read uncommitted data, that means nothing will execute. Is that what it means? In the previous example, you
So
show
it
one
will
example.
execute, but it will have read isolation level, which is read committed. Yes.
Okay.
Okay. So it prohibits from reading data that has been modified, but not yet committed. So when you commit, you see 200, 1200 value. That means that is stored somewhere, but it's not reflecting. Yes. So it prohibits reading uncommitted data in read commit mode. And repeatable read is same result if we run the same query multiple times. This is all you know, right? Now, anyone, what is serializable? What is serializable?
Sorry, what is serializable?
Serializable.
Okay, we can, like, there will be different form of saving the data basically. I mean,
No, this is not data serialization. It is transaction isolation level serializable.
okay.
Yes, so do not confuse it with the data serialization. This is different. So I'm putting up the definition. This means we will see the same result even if we run the same query multiple times, and also prevents other transaction from modifying our data. Yes. Basically, it's a repeatable read, but in this, you get the ultimate isolation level. You don't get any phantom read also. Right? Is this clear to everyone? because this is something you need to learn and understand very thoroughly. Yes, so dirty read. I'm repeating, reading uncommitted values is dirty read. Yes. Non-repeatable read. We are reading the committed value, but it is not durable. You read multiple times, you see different values each time. Yes. Phantom read is same as non-repeatable read, but it is, you are seeing different rows each time. Your query is like which involves multiple rows. Maybe like I want to see all the employees whose salary is more than 5,000. So I see one time I run query, I see two rows. Another time I run, I see some different rows. Right? So that's kind of phantom read. But what is all advisable is serializable. Because this, if you have, your application will run. So to build a large scale application, stable application, like Book My Show, hotel booking, flight booking application, you should have this isolation level. Accounts, banking application, you should have serializable reads. Right? But what is the disadvantage of serializable reads? There is a disadvantage. More restrictive the isolation level, less information is shared. So scalability is less, performance is less. So sometimes you may prefer read uncommitted, read committed, lesser isolation level also. Because if consistency is not important for you. Right? So for example, I'm putting tweets. If it's a database about tweets, I'm fine with non-repeatable reads. I'm fine with read uncommitted, or I may be fine with dirty reads also. Right? In some cases. So based on the requirement of your application, you would have to decide what you want to restrict, what you want to allow. Allow as much as possible, because this will give you better performance, better availability, and scalability. No, when there is update, you will see the right information. It will never be inconsistent read. Yeah. So if the data is repeatable read does not mean that if I see your bank balance now 1,000 rupees, throughout your life, you will be with 1,000 rupees only. If there are many transactions every month you are getting salary, you should see the repeated result, right? You should see the correct result. It should not be that, okay, you always see the, don't misinterpret it. It is logical. It is, yes, it is as per the norms of database that it will always show valid values, but yes, repeatable read is at that state, in that state. If between transactions, when you will do multiple reads, you will see the same results.
Sharan, read meaning updating something.
Read means reading, no update.
No.
Why
So-
why are you getting this doubt? Like, what is the meaning of read? Read is English word. Yes. Read is meaning reading, right? When I read, I don't write. Yes.
So you
read
are saying
is
that
like book. Yeah, you are fetching the data.
you're saying that let's suppose some specific transaction, let's suppose there's an account ID, and for that account ID, if someone is reading that data, and that time if someone is trying to update the balance, let's suppose, right?
Yes.
They cannot do that.
Yes, absolutely. Absolutely. Yes, you got the right point. Locks. This is what we will be covering now. This is how these are implemented internally. Yes.
Okay,
there are, yes.
so there may be problem. Let's suppose someone is reading. Reading means it's just hitting that, right? Once they are displayed on UI or something, then after that they can some other person whoever is trying to update, they can update, right?
Yes, yes, yes. But multiple people will be reading. You should always understand that
Okay.
if some data is there,
Uh-huh.
right? Say, assume this is the data.
Let's suppose
There will
balance
be
something like that.
writers, right? So assume these are the writers,
Mhm.
right? So you have W1, which is a writer. Yes. We'll make it smaller. You will have other writers also. Database is always shared between multiple people.
So you're saying single reader, multiple writer, right?
Readers will always be multiple.
Okay.
That's why you have the database.
So writing could be problem, right? That time if it is like locking it.
Yes, yes, absolutely.
So
But
let's up. Mhm.
you may allow while writing other readers, right? Yes, so you see here, this is reading, this is reading, this is reading. Yeah, but yes, you would like to have everything at the same time. This is what happens all the time, right? You have
So here
multiple people
R1
writing,
are
multiple people reading.
okay. So R1 let's suppose reading 1,000 rupees, R2 also reading 1,000.
Yes, and also definitely
And in
everyone
between,
is reading repeatedly, right?
yeah, R2 is also reading, and in between someone has written, updated, let's suppose.
And there are and they are reading multiple things. And in transaction, you have multiple data involved, right? So when you are reading, okay, let me draw like this. There is three data, right? Say, for example, you have customer, you have account, you have transactions, right? Or let's call bank details, anything, lot of things could be there. Yes. So for all the entities, you may have multiple read, write, and you may be reading something in sequence. I'm reading the account first, I'm reading the customer first. Okay, let's say I'm reading the account first, I'm reading the bank second, I'm reading about the customer third. So my order is A, B, C. Accounts, bank, customer. Right? Someone may be reading BAC. Yes. And then, yeah, let's say this is reading CAB. In any order they may read. So yes, if you do these transactions in same order multiple times, if you get the same results, this is serializable. Yeah. So assume some operation, it sees some data. Let's say this is the data which he sees. This sees some other data. Yeah. And this guy sees some other data. Right? So serializable means if he runs the same set of operations again and again, if he does this again, he will still see this only. He'll not get different result. This is what is serializability. Irrespective of what is going on in the background. This is the maximum level of isolation. And this is what is desired always, because if you perform same set of operations again and again, you should see the same data. Now let's talk about locks. I know there will be difficulties in understanding all these concepts, but yes, just remember these, it will become clear when we will be doing system design. I'll be referring them again, and then you will realize, oh, that two customers are trying to book the same hotel room. And one is able to book, other is not able to book. How can we have this? If they are trying to book at the same time, or if they have the last seat in Book My Show or in a flight, how can we ensure that if two customers are booking the seat at the same time, one gets it, other do not get it? Yes. So all these concepts we'll use. But yes, you should also understand this concept of locks. Locks are of different kinds. There are many kinds of locks. But what are important is there is something called shared lock and something called exclusive lock. Yes. So when you write, what do you want? Exclusive lock or shared lock?
Shared lock will be better, I think.
Let's see. Exclusive lock means when you are writing, no other resource, no other process can get this resource until it is released. And shared lock is, so basically, what does it mean? Only one process can modify it. Yes. This is exclusive lock. Shared lock is something which is multiple process read the data simultaneously. Shared lock is used for reading. This is used for writing. Exclusive lock is for writing. Because when I'm writing, no one else should update it again, right? You need exclusive right to write. While reading, maybe two people can be reading at the same time. There's no problem. So that is shared lock.
So we can say that book my show is the example of a exclusive lock. Should book it.
In all the applications, whether it's flight booking or seat booking or hotel booking or any, you need these concepts of lock. Otherwise, you will have two calls at the last seat available. Both of them will get the seat. Yes. So before writing, one will get the lock. No one else will be allowed. This way you will ensure that you have always consistency. Also in Amazon also, there is sale going on. Last item is there. Multiple people are paying for it. Buying, trying to buy, right? Maybe it's a iPhone 14 or something new. So they have to ensure that the number of orders are exactly equal to number of items available in the store. They have to ensure that there is a locking mechanism in place. Reading is fine. Reading, you have to have shared lock, because only thing you may have to ensure is when you are reading that no one else is writing.
Yeah.
Right. So sometimes you may want that when I'm reading, please do not update it.
So you are saying that, let's suppose,
so that's the use of shared lock.
yeah. So let's suppose if we'll talk about book my show. So book my show actually locks for some time, maybe 1 minute or 2 minutes.
Yes.
Right. Do you think that same thing is happening with IRCTC as well? Like IRCTC is the Tatkal booking, right? So that time actually, I think how actually it applies.
Yes. Never. Okay. There are some situations where two passengers are fighting. I've seen many people fighting. Oh, this is my seat. This is my seat. Right. You would have also noticed.
Yes. Yes. Yeah.
Correct. Correct. There could be other reasons also for that. Maybe some other bug, or could be shared lock, right? Or could be means not improper locking. Yes. But yes, no,
Locking
you
can
have to
also make
ensure this. Otherwise, you will have less people are fighting in the cinema theaters and even lesser. Yeah, sometimes I've seen in the flight also. But yeah, there could be many other reasons for people fighting or people getting assigned to the same seat. Right. So there could be some bug, or both of them booked at the same time, or somehow, this got allocated, because there are multiple steps in booking also. Because you reserve the seat, you pay it, you get the confirmation, right? So that's why the airline takes some time to give you this status that your booking is confirmed. So this is all important in whether you are doing an e-commerce application or doing a other application like booking of hotel room or seats or anything. But yes, you have to take care. If you are locking, you do not have this situation of deadlock. Right. So what is a deadlock? Deadlock is also something you should understand, because if you are locking things, you may get into deadlock. Is a very important concept. Say, assume we have two processes, right? They have two things, two tables. Let's say there are two tables. So for doing some transaction, assume you need a lock here, you need a lock in both the table, right? Assume you have programmed well. This is the tables, this is the database. You have process A, process B. Both are modifying. You get exclusive lock, right? So let's say I write here exclusive lock, right? So we have here table 1, let's say T1. We have here table 2, T2, right? So to perform the transaction, we need a lock on T1 and lock on T2. Same is the case required for B process also. It needs lock on T1, lock on T2. Yeah, maybe some other process also it needs lock. Yeah, so maybe in T3 also, but yes, these are the two common things. Both the processes started the transaction at the same time. See how common this situation could be. This is a very, okay, sorry. Oh, I got stuck. Okay, just I'll fix this. While I'll share the notes, but yeah, right now you have to live with this. So yeah, for transaction B came, it acquired the lock T2. Now you got into the deadlock because A is waiting, thinking that yeah, sometime T2 will, yeah, the lock on T2 will get released. But B is waiting. B is also waiting because it is seeing that yes, A has acquired the lock. Now it is waiting. So now you got into the deadlock situation. No one is able to use the app. No booking of the train, no booking of flight, etc., or no ordering of item will happen in that case. Correct? This is a deadlock situation. What is the solution? How do you prevent the deadlock? You have to detect the deadlock first. If you can detect the deadlock, then you can start releasing the lock, seeing that there is no progress happening. Yes, so there are various strategies of preventing deadlocks. One is don't allow the table locks happen. Always allow smaller chunks of lock. So there is less possibility that there will be conflict. So locking data in the smaller chunk, that is one strategy which can prevent deadlocks. Right, so let me talk about preventing deadlocks. So the first strategy is lock data in smaller chunks. Second strategy is you ensure
Deadlock means you are saying that A has been logged by T1 and B is waiting for that.
yeah, is shared, no, that for executing the transaction, A needs both T1 and T2. This is what it needs. Yes. For completing the transaction, B needs lock on T1, lock on T2, lock on T3, right? These are the two things which they need. So if
Okay.
this situation would have been there, B would have completed this transaction. But somehow what happened is A started coming, it acquired lock on this. Maybe B acquired lock on T2 and T3 also it acquired. But yes, it saw that, okay, A has locked this and A is also trying to lock T2. It's not able to do that because it's locked by. So then there is a deadlock. Clear? So you will have a deadlock situation in this, and these are the solutions. One is lock data in a smaller chunk rather than maybe if there is a row level lock, use that. And other is you provide a time, maybe this process can only lock for 10 seconds or 5 seconds or 1 second. So yes, after this, everything gets released. So don't hold the lock for too long. That could be another strategy for preventing, but you never know. Once they release, they again may try acquiring again and they may get into deadlock. But yes, it will get resolved sooner or later. And then other thing is do nothing. Wait for deadlock to to happen, and then have some process which can detect the deadlock. And then once it is detected, it can resolve the deadlock. Right? Because there are some products available which does this. Right? So these are the strategies. But the best way is in the design stage itself, take care of preventing the deadlock. While programming, always understand that this is one situation which may happen and take care of this at the architecture level. Yes. So what you can always do is, I will only get the resources in the cyclic order, maybe T1 first, T2 next, T3 third. This way, always processes will have a priority of which resources to look for first. This way, you will be able to prevent the deadlock. Right? So these are the deadlock prevention strategies. So be ready next time. We will discuss low-level design. The coding principles, which will be solid principles, dry principles, and various other principles. And we will also discuss design patterns, right? So that is something I'm planning in next classes. But yes, probably in between, I'll also cover some problems which involves database design. But yes, see, these are all the considerations you need for using relational databases. But yes, we will also cover NoSQL databases also. And in that, there will be more considerations and more flexibilities. You will understand when to use what in next few classes when we will be discussing NoSQL databases. Then you will get good clarity on what is the right approach to use the data. But yes, I want to get into the problem solving mode more, less on the theory part. But yes, theory is important. But yes, I will keep posting also the assignments. So you try attempting doing tiny URL, system design of tiny URL. I've already taught you, but do this more thoroughly. System design of tiny URL. I am discussing with the people in LearnBay to have a folder for submitting assignments so that it's easier for you to submit the assignments, and there is a better way of collaborating between us. Right? Sharding is another thing. Yes, I am getting a lot of times the request about sharding. Okay, we can discuss that. Yes, so let's discuss about sharding next. Yes, because yes, this is nice suggestion, Ramesh, that sharding we should discuss because we have covered relational databases. We should cover sharding. So yes, in some of the existing system design, we can use sharding. Let's discuss sharding next time. Sharding could be important, say, in the design of lead code. That would be one good way of sharding. In design of tiny URL, you can also do sharding. In design of Twitter, Facebook, we can use sharding. Basically, Twitter uses MySQL, relational databases. They use a lot of other databases, but it started with MySQL and it uses extensively sharding. So sharding we can cover next. Right, so that you guys will have a good understanding of relational database, and then we'll move to NoSQL databases. I see very less people are interacting. Yes, keep interacting. Keep doubts, keep answering doubts, keep asking doubts. Yes, but also understand these are the theoretical sessions, but yes. So keep posting the doubts and any questions. Feel free to use the WhatsApp channel. So yes, have the thought process going even after the class. Have the thought process or have practice going on even after the class, because you now also know how I am practicing these things. Because if you use some cloud tools, you may install Postgres database also. Right? Installing Postgres database on your laptop will take hardly 10 minutes. If you need instructions, I can share you the instructions for installing Postgres database. But yes, I can quickly share you in a minute how to install Postgres database. That's the best way to learn any database. It's very simple. I'm using this tab. You go to this site, postgres.org/download. Whatever is your database, what is your operating system, choose that operating system, get the installer, run it. You have the database installed. You can do this for MySQL also. MySQL also has a download page. Whichever you prefer, you can choose that here, downloads, and get the MySQL database. So what I would suggest, have at least one database in your operating system, either MySQL or Postgres. These are lightweight databases. You can switch it on and off as you need. I like Postgres better than MySQL. Some people may like MySQL, so whatever is your liking. I would ask you always, put your favorite database, MySQL or Postgres. Put in the chat what you like, MySQL or Postgres, or don't know. Oh, let me put this. This is an interesting poll. I'm creating a poll. So first choice is MySQL, second choice is Postgres, third choice is other, right? So yes, tell me. You got the poll?
Yes.
Right. So what is your favorite database? MySQL, Postgres, other also specify in the chat. What is other? Okay. MySQL is winning. Yes. Okay. Only 5 people? What about others? But yes. Pick your favorite database, install it. You can run all the SQL commands. But yes, the behavior may be slightly different. Some nuances will be there. Maybe the money data type is not there in MySQL, or you may encounter some other data type like currency is there, or some differences, slight differences will be there. But the concepts are mostly the same. Yes.
So which one is a lightweight actually? Is it MySQL or Postgres?
Both are very light.
Okay.
Yes. Postgres is also, I am running it, never face any problem with it. But yes, it's still lighter if you want to know. There are still lighter databases also available. These are
which is open source.
Derby. Yeah, H2
But this is not open source, right?
is open source, right? H2 database, Apache Derby database. These are even lighter. SQLite is also very light. You can try installing them and playing around with them also. Any of these. But yes, not had fit. These databases are so light that
Can install MySQL. I think that will be
yes,
fine.
they are not, you don't feel that you need power, right? So Postgres has the power and MySQL also has the power. But yes, these lightweight are like, if you want SUV experience, SUV, yeah, you need to get that SUV. You can't get the SUV experience in an auto rickshaw, right? So these Apache Derby H2 are auto rickshaw. They can help you learn, but they are not that good enough to be used in production environment. But yes, we'll go through them also. When we will be covering microservices, we will be covering some topics. I can help you out doing some projects in Spring Boot and all. I may demonstrate some Spring Boot because theory, if it is backed by practical examples, it sticks to your brain. Just if I can share concepts, then you will not remember it. In next few days, you will forget it. But yes, now since you have seen all these concepts, whenever you will be asked all these questions, you will be able to recall better, and you will also be able to reason better because you have got some practical experience. But yes, more you keep exploring, get into the project mode. Whenever you are doing system design, we act like an architect. So architect do a lot of conceptual work, but after the conceptual work, they also do a lot of prototyping, playing around, evaluation. So you have to do both these things, read a lot, learn various concepts, and at the same time, get your hands dirty with all these concepts you are learning, evaluate them and figure out what are the best options. Yes, right. So happy with all the database concepts. We have covered now all the relational database concepts. Definitely, no, I know you guys are not happy because it is good to be not happy because in system design, when you will use it, then you will become happy and you will understand it in practical way. Because now I'll ask you some system design, like design for good isolation level, ensuring transactions, etc. Because you may design some database, but then when interviewer will ask, how will you take care of that no two users are booking the same room at the same time if there is only one remaining? Then you can say, okay, I'll have exclusive lock. I'll have transaction isolation level serializable, or I'll not allow read, uncommitted read. All these words, if you use, he may ask you, okay, there is possibility of phantom read or dirty read. You can then answer that also. So these concepts are very important. They will help you to clear interviews, and it will be the decider sometime between you getting selected and rejected for system design interviews. And these are definitely very important on all cloud-based applications as well. Okay, see you then. And
Hello,
yes.
Tarun.
Yes.
I have one more doubt. So in the future classes, are we going to do something inside the Flask, the backend part? Are we going to discuss that?
We will be not going into the implementation.
Mm-hmm.
So yes, we will not be doing Flask and all. You can do this as a project. I can guide you for that. But yes, specifically will not go into, but we'll be covering many concepts which you will be able to relate to, and it will help you understand Flask better, right? But it's like,
Okay.
will not be, say, if you are asking, okay, will you be driving if someone has craze for, say, a bike, yeah, a Yamaha bike, or will not be exactly driving, but yes, we will be driving bicycle, and you will learn, and this will definitely help you to try out more complicated things and do real implementations in whatever technology you use. But yes, we can cover. But yes, if I see that, okay, we are covering all the topics and we have some free time, we can cover that. We can cover that. So I can see we have around 3 months of time, 25 classes. So if we are done with most of the problems, then we can take up something which can be useful for you in the real project and domain specific as well. But yes, right now I have prioritized other content which will help you clear the system design interviews at the conceptual level and for FANG companies, bank companies. In FANG and MANG companies, you will not be asked on Flask. So I would suggest all of you to have a goal towards cracking big companies like Google, Microsoft, Amazon, Facebook. And in all these companies, and also many startups are there, they may not ask technology specific questions. They'll ask architectural and computer science concepts. So what all we covered are pure computer science concepts because can be applied in any database. What all concepts I taught you, you can't say it can only be working on Postgres. Although we covered on Postgres because of convenience, but yes, application of all these concepts are valid for any database, whether H2, Apache Derby, Oracle, or MySQL, or any other database.
Okay.
Anything
Thank you, Tarun.
else?
Yeah, that's it.
If nothing else, then we can close this class. Next time we will start doing some problem solving. See you.
Good night, Tarun. Bye.
Good night.